Please welcome Getup Cloud's Mateus Carucci, CTO and co-founder, who is joining us today from Brazil.
Thank you. As I said, my name is Mateus Carucci. You can call me Matt for short. I am the CTO of Getup Cloud, and I'm here to talk a little bit about how Getup Cloud hosts its OpenShift offer on Azure. My partner, Diogo Gebel, raise your hand, please, Diogo. We are here both for gathering in KubeCon, so if you want to talk to us, just reach. As you can guess from my bad English, this is my very first talk in English for English-speaking attendants. So I wish I had a French accent. Unfortunately. So Getup is a Brazilian company specialized in PaaS, founded 4 years ago by Diego Castro, and I. In fact, Diego, not this guy, Diego and I share the CTO title. He's more ops, and I am more dev. Diego could not join us here because he's in Buenos Aires, Argentina, getting married. So I can say Getup Cloud is a multinational company. So we have this public PaaS offer based on OpenShift Orange. We also do on-premise deployments for customers and consulting, mostly helping the consumers to understand and embrace this cloud-native thing. We focus on marketing agents, mainly running digital campaigns for big brands, and choose OpenShift for the same good reasons we all know about already. Before diving into the technical details, I'm going to tell you about this case, a huge success, which was our very first case running entirely inside OpenShift v3. It is a digital campaign called Heineken Up on the Roof. It's a free VIP party at the rooftop of Martinelli's building, an iconic skyscraper in São Paulo, amazing view of the city. The application was very simple. They built a Facebook app to give 400 free passes for the people from Facebook. So every Monday, exactly at 3 p.m., the list is opened, and all you need to do is to register yourself with your name and email in a simple web form. It seems easy, but don't fool yourself. Where there is free beer, there is a huge crowd. And not free as in software, by the way. The tickets finished in 9 seconds, and every week there is more and more crazy teenagers trying the luck. So this is a classic example where you need speed when scaling research. The new architecture of v3 has made it not only possible, but really simple to do. All the client had to do was to launch new containers a few minutes before the traffic spike and upgrade it to 1 or 2 replicas 2 minutes after that. It was something impossible for them to do before they reach us. So a little bit of our history. We started with V1 beta around November 2012, and we keep it to August 2015. During this time, our only offer was based on OpenShift v2, which was born in AWS. As OpenShift v3 was gaining territory, we decided it was time to dig into it and officially join the container revolution. This new technology, inspired us to reach for a new provider. So we start to look for a cloud provider that could be technology compatible with this new platform, easy to deploy, offering tools for automation and fast recovery, reliable with great and affordable support plans, and economically viable so that we could pay on our own local currency. The first v3 deployment happens by the end of August 2015, and by mid-November, we made our first private beta release with some hand-picked customers, Heineken being the first, running under our care. So we configure, we deployed, and we run the application all the client had to do was to validate and enjoy. GA comes in July 2016 for Brazilian customers only, with 100 bucks to trial. This gives access to all container types and sizes, plus chat and forum support. It's the real experience, no limitations on any aspect of the system. So why Azure? Everybody asks me, why Azure? Even not being the first to enter in the Brazilian market, from day one, Microsoft has shown commitment with startups and developer communities, from stuff like charging in local currency to support for creation of new services and applications. Microsoft offered us top quality engineers, helping us to develop and improve our own product. Any other technical issue that wasn't available at the time either was on the roadmap or wasn't relevant enough for us to take risks with another provider. One feature worth noting on Azure is the availability sets. It's how Azure handles AJ and redundancy at host level. Each application tier is assigned its own availability set. So masters, etcds, and pod nodes, and Ceph cluster. It works by automatically spreading the machines across different fault domains, each one with its own power source and network switch. In case of maintenance from Azure, update domains guarantee that only a portion of any given service will be unavailable. Only one update domain will reboot at a time. We don't even have to think about where to allocate the hosts, because Azure does it automatically for us. OpenShift v3 lands a whole new concept when we talk about deployments. Master and etcd are made to last, while any other component are simply disposable. That means you need to keep constant backup of those two guys, even if they are redundant. It's simply too risky to lose, let's say, etcd and have the entire cluster vanishes. On the other hand, if a node goes down, there's no need for alarm, metaphorically speaking. All you need to do is to create a new node and join it in the cluster. Piece of cake. This mechanism is working really well for us and has proven as a high value in our day-to-day operations. I must say it's a great improvement over OpenShift v2. And in order to provision new machines, we use Azure's Resource Manager. It's basically JSON templates that describes which service we want to create and configure. And we split our infrastructure in 3 parts, in 3 different subnets: public, private, and SAN. Security groups are attached to subnets instead network interface. So we have only 4 security groups, which is fairly easy to maintain and reason about. So the first subnet, the public network, is made of master, web router, instance, and jump nodes. They are the only components facing the internet. Traffic manager plays a critical role in the infrastructure. It gives us the high availability for our public endpoints. Traffic manager is a DNS-based load balancer that provides automatic failover by monitoring endpoints. And the traffic is distributed evenly across each set of endpoints. Also, the weighted pattern allows you to increase web routing layer on small steps by simply adding smaller routers with smaller weights. You don't need to go big on a single shot. There's only one drawback so far. It takes a little bit, up to 30 seconds, to invalidate the DNS cache as soon as an endpoint goes down. The routers run the AJ proxy OpenShift imaging. We don't use the native AJ solution, Pacemaker, because it doesn't work in the Azure cloud yet, because there is no multicast availability. At least didn't exist when we implemented this. And jump nodes are the associated endpoints in the network. They are used mostly for administrative tasks where manual intervention is required. The major part of the cluster lives inside the private network. It's consisted of ETC clusters, cluster with 3 machines with data disks attached to each machine. As they are only accessed by the masters, it makes completely sense to hide it from the outside world. Infra nodes host the systems for metrics and logging, namely Hawkler, Hipster, Cassandra, Elasticsearch, and Kibana. And the most important, computing nodes that hold the user pods are also placed on this network. We choose Ceph to hold the persistent volumes for the pods. It's a centralized system, no need for a master, so we eliminate a single point of failure. The cluster, and the entire cluster lives inside its own subnet. At first, when we implemented the Ceph cluster, SSDs wasn't available in Brazil, but we figured out how SSD could be used. We figured out that SSD could be used to hold the journal, while persistence could be placed in the regular data disk. So we have a good balance between performance and cost. And since this configuration is not the default for Ceph, we had to tweak a little bit the Ceph install scripts and startup to ensure there is always a valid journal on ephemeral disks right after the boot of the machine. On our operations, we rely on New Relic and PagerDuty for monitoring and taking care of the action chain for the whole infrastructure. As soon as something goes down or presents degraded performance, a ticket is created and assigned to someone from the operations team. If that person can't respond in a reasonable time, the ticket is quickly escalated until it reaches my own phone and wakes me up in the middle of the night. No, just kidding. I don't do anymore. So when there is the need to expand the cluster or replace a component, we perform 2 simple steps. First, we trigger Resource Manager to create a new host. It installs all the dependencies and places the machine in the right subnet. And then we run Ansible playbook, for example, the playbook for the node scale up, so it can finish the configuration and we are done. We plan to automate at least part of this process in a near future. And we are looking to Azure scale sets so we can someday out-recover and out-scale. In order to upgrade OpenShift itself, we follow a very straightforward procedure. We start by creating a stage infrastructure, which is a mirror from the current deployment version using Resource Manager and Ansible. We apply the standard OpenShift update process, ship it with the playbooks. We test and validate, both automatically and manually. And fix and send feedbacks to the upstream if anything needs to be fixed, of course. When everything is fine, is okay, running well, we deploy in production using the blue-green model. We start by updating playbooks to master, etcd and routers. We create the compute nodes with the new version. We evacuate and activate the old nodes so the applications can migrate from the old installation to the new one and delete the old nodes. During the first 5 months, based on our experience with these beta users, we noticed the need to simplify the user interface and decided to start our own web console. It's for dummies. It approaches the platform from a more traditional point of view by hiding many technical aspects from the user, which means we expose less features. For the tech savvy, there's always the good old OpenShift client console tool, and of course, we expose the full API for the user. So the first pull request contribution allows you to use Azure Blob Storage as a Docker registry backend. And as you may know, registry is where all user images are stored. So it's very, very important to keep it scalable and high available. All you need to do is to insert your account credentials into the registry, and it's the registry configuration, of course, and it's done. We have made some small contributions to Ansible with fix and new stuffs. And we are also playing a little bit with OC Observe, connecting real-time events from all the namespace into the Azure's event hubs. The event stream feeds Stream Analytics, where you can group, filter, and transform data. And the last step is to use Power BI to plot that data, which gives a better overview of what's going on inside the cluster. We're doing the same with AJ-Prox logs, where we can easily find out, for example, where are the most network grading projects, what are the most network consuming clients. This is what we get from this process. And this is the first time we're talking about it, but we're going to America soon. We plan to launch the first quarter in 2017, charging in dollars, don't worry. If you want to be informed, keep in touch with us on our website or Twitter. Muito obrigado, and enjoy the conference. I'm open to questions.
First of all, thank you so much for using Microsoft Azure. We're from the Azure team. Very happy to have you here. So, quick question. You talked about the traffic going up, that you are predicting traffic. What are you actually using to increase the number of containers, or for scaling the traffic? What you are getting?
If I understood, you wanna know why don't we use the data to outscale?
Yeah.
Time.
Okay.
We just started to play with BI.
All right.
Like a month ago.
All right. Thank you.
You mentioned how you upgrade nodes in a rolling update fashion.
Mm-hmm.
How about the masters and the etcds?
It goes on the. I'm having it here. The playbooks. You apply the playbooks on.
You're still able to do that in a rolling fashion without standing up a parallel environment or something similar? Because if you're upgrading with different versions, or think a different version of OpenShift, for example, and you want to roll in an upgrade, are you able to do that node by node,
Yeah.
master by master, rather?
Yeah. We do one by one.
Right.
It's not single shot.
Another question? All right. Well, with that, thank you for coming up from Brazil, and thank you for using OpenShift Origin, and we'll go to the next panel in a second.
Thank you.